Hi students, welcome to physics class. Today we are going to discuss some important definitions. Angular displacement. Angular displacement. Angular displacement, which is denoted by theta. Now go for discussion. Take a circle. This is the center. This is theta. This is an arc. So this one is a point P. This is point Q. Here this is radius small r. This is O. The angle is theta. The time taken is small t to travel from P to Q. It is radius r, where PQ is equal to consider as S. So PQ is considered as S. That S is equal to arc. That S is equal to arc. Think like that. Now go for elaboration discussion. Consider an object moving along a circular path of radius small r in anti-clockwise direction. In anti-clockwise direction. In anti-clockwise direction with center O. Full stop. Let the position of the object of the object changes from P to Q in time small t, where angle POQ is equal to theta. Here Here theta is known as angular displacement. Angular displacement. Once again, of the object in time small t. My dear students, once again I am repeating this one. Listen carefully. Consider an object moving along a circular path of radius small r in anti-clockwise direction with center O. Let the position of the object changes from P to Q in time small t, where angle POQ is equal to theta. Here theta is known as angular displacement of the object in time small t. Now it is defined as the angular traced out by the radius vector at the axis of the circular path in a given time, that is angle is equal to arc by radius. Therefore theta is equal to PQ whole by OP. What is PQ? S by what is OP? R. Therefore theta is equal to S by R. Consider this is equation number 1. Now angular displacement is a vector. Angular displacement is a vector quantity. Angular displacement is a vector quantity. Now units. Its its unit is radian. Its unit is radian. Going to discuss about angular velocity. Angular velocity. It is denoted by omega. Now, it is defined as it is defined as the time rate of the time rate of change of its angular displacement. Its angular displacement. Its angular displacement. It is denoted by omega. Once again, it is defined as the time rate of change of its angular displacement. It is denoted by omega. Units. Radian second to the power of -1. Now, dimensional formula. The dimensional formula is m0 L0 2 to the power of -1. Now, omega is equal to angle traced whole by time taken. Therefore, omega is equal limit delta t tends to 0, delta theta by delta t. Therefore, omega is equal d theta by dt. Consider this is equation number 1. Since limit delta t tends to 0, delta theta by delta t is equal to d theta by dt. This is the point we have to remember. Now, angular velocity. Angular velocity in the bracket omega is a vector quantity. Now, take a circle this is the center, a body, an object moving in anti-clockwise direction, anti-clockwise direction. Consider, take 2 points P and Q. It is S arc. The time taken is T. This is radius R. This is point O. Where is the angular velocity here? Take a straight line, that means vertical upwards. This is omega. It is a vector. Okay, now it is theta. For anti-clockwise, for anti-clockwise, rotation, for anti-clockwise rotation of the point object, of the point object on the circular path, the direction of omega, the direction of omega is directed upwards, Once again I am repeating this point. For anti-clockwise rotation of the point object on the circular path, the direction of omega is directed upwards. The meaning is, take it is a circle, the particle which is revolving like this. Okay, now where is the angular frequency? This is the angular frequency. This is the meaning of this one. Okay. Now take a circle, take the center O, point P, point Q, the arc is S. The time taken from Q to P is T. This is radius R. The angle is theta. Now here, particle which is moving in clockwise direction. This is clockwise. This is clockwise direction. Now see, for clockwise rotation, of the point object on the circular path, on the circular path the direction of omega, the direction of the direction of omega is directed downwards. That means this is the angular frequency direction. Now which direction it is? Anti-clockwise. Here clockwise. Now a particle which is moving in clockwise, take a radius from the point O center, take point Q and P. The particle is moving from Q to P. In that case, the angular frequency is downward direction. For clockwise rotation of the point object on the circular path, the direction of omega is directed downwards. These 2 points are very, very important. Now we are going to discuss about angular acceleration. It is defined as the time rate of change of angular velocity. It is denoted by alpha. It is a vector quantity. It is a vector quantity. Units radian second to the power of -2. Dimensional formula m0 L0 t to the power of -2. Once again, it is defined as the time rate of change of angular velocity. It is denoted by alpha. It is a vector quantity. Unit is radian second to the power of -2. Dimension formula m0 L0 t to the power of -2. Now take a circle. Take radius, this is point P on the circle. Take point Q on the circle. This is also radius. Take center is O. Here the angular velocity is delta omega, and the time is to travel from P to Q is called delta T. In this case, alpha is equal to limit delta T downs to 0, delta omega by delta T. Therefore, alpha is equal d omega by dt. Consider this is equation number 1. Since limit delta t tends to 0, delta omega by delta t is equal to d omega by dt. Therefore, alpha is equal to d omega by dt. Consider this is equation number 1. So, angular acceleration is equal to angular velocity by time. Now, relation between linear acceleration in the bracket A and angular acceleration. Once again, relation between linear acceleration A and angular acceleration. What is angular acceleration? Alpha. This is our concept. Once again, today our concept is relation between linear acceleration A and angular acceleration alpha. Now, linear velocity is equal to angular velocity into radius, that is V is equal to omega into R. Consider equation number 1. Differentiate with respect to time. Differentiate with respect to time. Therefore, dV by dt is equal to d by dt of omega into R. That is equal to omega into dr by dt. That means d by dt I taken inside. Therefore, omega is constant taken outside. Therefore, dr by dt written here and omega I wrote here. Therefore, dv by dt is equal to omega into dr by dt. Therefore, dv by dt is equal to omega into dr by dt. Now tell me, what is dv by dt? Acceleration A. That is equal to omega into what is dr by dt? Velocity V. A is equal to omega into V. Consider equation number 2. dv by dt is equal to A and dr by dt is equal to V. And also dv by dt is equal to d by dt of omega into R. Now, dv by dt is equal to, now take R outside, R into d omega by dt. Therefore, dv by dt is equal to r into d omega by dt. What is dv by dt? A is equal to r into what is rate of change of angular velocity, angular acceleration. The rate of change of angular velocity is called angular acceleration. Consider this is equation number 3. Here since dv by dt is equal to a and d omega by dt is equal to angular acceleration alpha. Therefore, linear acceleration, linear acceleration is equal to angular acceleration into radius. Therefore, a vector is equal to alpha vector into radius vector. My dear students, this is very important concept. I hope you understood this video. Thank you very much. Thank you very much for watching this video. Thank you.